So, uh, good afternoon for all of you. Hope you all can hear me well. So, and also you can see my shared slides as well. So, let's start with today's lecture. Today we are going to have the fifth lecture. So, any questions from the previous lectures? Anything if you want to just need any clarifications or something like that? So if you want any kind of any questions about the practicals and all as well. So if you have any questions, please raise those questions right now. So here to this JIT courses, so when we check about the participations, now only we have 32 students are there. So I don't know whether you guys are watching the videos, and there are also I can't I don't see any kind of improvements there also. So you haven't seen last two videos as well. So what happened? Any questions from the previous lectures? Okay. So if you don't have any kind of questions, let's move from here. Today we are going to talk about marks and channels in data visualization and also visualization techniques. Tuesday 1 to 3. So uh, so Tuesday practical means ප්‍රක්ටිකල්ස් වෙනමම ඔගොලන්ට allocate කරලා තියෙන දවස්වල තියෙනවා. මේ මම කරන්නේ lecture එක කරන්නේ Wednesday 1 to 3. So that is totally different. දැන් ඒ කියන්නේ practical එක වෙනමම යනවා and here the lecture එක වෙනමම යනවා. So that is it. Okay. So okay, anyway, let's start from here. So today we are going to have the fifth lecture, that is marks and channels. Okay, let's go through with these slides itself. So here we already discussed about these idioms and all, and also how to systematically analyze idiom structures as well. So I explained the entire this visualization, how we start from the domain situations and then how we move up to this data task abstractions, and then as the third point, how we visually encoding or else how we interaction idioms as well, and finally how we derive the algorithms as well. These ones we discussed earlier as well. So when it comes to visual encoding, as you see, the third point would be, so last week we up to this point we just discussed about the domain situation, and also we just discussed about the data as well as task abstractions as well. So here today we are going to talk about the visual encoding or interaction idioms as well. So let's start with the visual encoding. So when it comes to visual encoding, how to systematically analyze idiom structure? What do you think? There is a question, we can raise this question, that is how to systematically analyze these kind of idiom structures. So we have first one would be the bar charts, and the second, third, the fourth would be like scatter plots. But they are also in the very first graph itself, we have used only one color. But here again, we have used two colors, but with the same size of circles, dots. And but here we have like used two colors. And also with the, it will basically like differs from the what differs from these magnitudes as well. So you can see these kind of changes from the first chart up to the last chart. So when it comes to marks and channels in data visualization, marks means the represent items or links. So in the chart itself or else in the graphs itself, so marks are the represented items or else represented links. But for the channels means that is change appearance of marks based on attributes. So change appearance of marks based on attributes. So here what will happen? Marks for items. Basic geometric elements would be points, lines, and interlocking areas. When it comes to points, that is, it will be like 0 dimensions. It's kind of a 1 point, single point. But when it comes to lines, so lines are like connecting those two edges, or else we can say connecting those two points. So here it would be like one dimensional. And for the interlocking areas and all, it would be like two-dimensional element. It would be two-dimensional element. So when it comes to 3D marks, what happened under these 3D marks? It will like be volumes, which is rarely used. So 3D marks are kind of very rarely used. So when it comes to marks for links, what happened here? We have the containment and also the connection. So containment in the sense we have the dots or else the nodes or else the points. And when it comes to connection itself, you can see like we have mapped with these points or else we have mapped with these links with the branches as well from these branches itself. So we have the connection line. We have the connection lines itself. Okay. So from the containments means actually the nodes itself or else the points or else that is it. Okay. And for the containment can be nested and for the containment can be nested. So here what will happen? It will be like nested loop. It will be like that. So it will be nested. Okay. So these containment එකකට වගේම තව එකක් ඇතුළේ තියෙනවා. So may Sophia, if we take the word Sophia, then what will happen here? If we take the word Sophia, then what will happen here? It will related to, it will connected with this orange one and this yellow one, as well as it will be under these two, purple and the pink rectangles as well. These are kind of nested ones. Okay, so here with the channels, so control appearance of marks. So when it comes to control, so now we have discussed about the marks. No? So if we talk about these channels, what will happen? So when it comes to channels, generally control appearance of marks. What does these channels do? These channels are controlling appearance of marks. So proportional to or based on attributes as well. So these channels are like those are kind of proportional ones, proportionals to or based on attributes as well. So maybe sometimes we are using these channels as visual channels, visual variables, or else retinal variables, and also visual dimensions as well. So if you check with graph itself, so these ones are comes under these positions. So the control appearance of marks. So it will be like in a position. So it will be horizontal, it will be vertical, it will be both used X and Y axis. So when it comes to shape, we might use triangles, asterisks, lines, and multiple, I mean, custom relationships, custom shapes, and also with the size, we have length, areas, and from the volumes itself, we have like we can have these kind of volumes, and also with the colors also we might have different colors, and also tilt also we might have different lines as well. So the definitions would be marks and channels. So marks would be geometric primitives. So marks, when it comes to marks, geometric primitives are comes under these marks. So we have the points, lines, and also we have the areas as well. So if we talk about these channels, what will happen? So we just wanted to control appearance of marks as well. Okay, so give me 1 minute. I'm getting a call. Give me 1 minute. Okay, so you can hear me, right? Okay, I assume that you all can hear me. So anyway, for the definitions, we have marks and channels. So when it comes to marks, so we normally use this geometric primitives under this mark. So we have points, lines, and interlocking areas as well. And when it comes to channels, we have control appearances of marks. So for example, we have position, shape, size, and then again color, tilt, and volume. These are kind of few things. So these are kind of few these are kind of few things which we use to generally control appearance of marks. So when it comes to channel properties, so these channel properties might be differ from one to one. So how we can derive, how we can think about these ones, that is, so generally type and amount of information can be conveyed to human perceptual system. For example, when it comes to, let's assume, if we want to show the population density or something like that, in kind of a special areas, then we can use like uh, so if it is kind of a large population, if it has like a if the population density is kind of a very high, then that means actually we have like this the larger squares. Or else if the population density is low, we can use the same shape but with the smaller one. So that's how we are going to make small changes in our charts as well, visualizations as well. So when it comes to channel, properties differ. So type and amount of information that can be conveyed to human perceptual systems. So again, visual encoding is there. So for the first one, we have analyze idiom structure as combination of marks and channels. So what are the comments on first? What are the comments of the first graph? That is, it will be like vertical positions. It will be a vertical bar chart, and we have used marked lines. So we have used the vertical points as well. So with the second chart, we have used vertical positions as well as the horizontal positions as well. So we need two coordinates to mark these places, no, mark these positions. No. So that means we have already used two ways. One is the vertical position and the other one is the horizontal position. So mark would be here. We haven't used any kind of lines. We have used only points. Okay. And for the third one, what will happen? So the vertical position or the horizontal position. Then again, we have used vertical positions and also the horizontal position. But uh, instead of the previous one, the different is earlier we had used only one color. But here we have used like two colors. That is, the color hue will be matters in the third and fourth charts as well. So, and also mark would be the same as the second chart, that is point. With the fourth one, what would be the difference? So difference would be all three which were in third graph, it's same as here. Vertical position, horizontal position, color hue is here, but only difference is the size. That is the area. And here we have the point as well. So again, marks as the points. Points as the mark. Any questions up to this point? Visual encoding point. Any questions? Is it clear? Can someone confirm me whether it's clear or not? Okay. So if I move from here, so redundant encoding. Here with the redundant encoding, we can use multiple channels as well. So in these multiple channels, we might need to send some stronger messages, and also sometimes though we send some stronger messages, but we might use some few channels as well. So see, the length and the luminance of the colors will be mattered. That is redundant encoding. When it comes to marks as constraints, here what will happen? It will be like in the mathematical way. If we consider it up like the mathematical point of view, then mark as a constraint, yes, geometric primitives have kind of few dimensions. Generally, geometric primitives have dimensions. So when it comes to points, it would be like 0 dimensions. And when it comes to lines, it would be like 1 dimension. Okay. And if it would be like interlocking areas, if it is interlocking areas, then what will happen? It would be like 2-dimensional one. We are using both axes. Okay. So constant view, if it is a constraint viewpoint, so the math viewpoint, that is from the math view, that is now already we discussed about that one. With the constraints points, what will happen? With the constraints view, mark type constraints, what else can be encoded? So in the point 0, we have constraints on size and also can encoded more attributes with size and shape all. From the lines itself, one constraint on size, that is length, we can only show, or we can only visualize the one constraint, and one constraint on size and the length, and also can still size code other way with as well. So for this interlocking areas, two constraints, that means 2 dimensions can be checked. Checked on size, so length or else width, and also cannot size or shape codes as well. So interlocking, that means the size, shape, position will be matters here. To quick check, you can size code another attribute. you can size code another attribute as well, or else you can consider a size, or else you can consider a shape also in use of visualizations. So is it clear? Okay, let's move from here. So scope of analysis, simplifying assumptions, that is one mark per item. 1 mark per item, or else single view. So later on, multiple views, maybe sometimes we just need to have multiple views, or else multiple marks in a region. And also some items not represented by marks as well. So there we might use aggregations and also filtering options as well. So when to use which channels? How can we think? How can we think about what are the when we just wanted to use which channel Kela? How can we decide? So that's because of that's on the expressiveness and also the effectiveness. When it comes to expressiveness, match channel type to data type. First, we have to match the channel type to the data type as well. When it comes to effectiveness, maybe sometimes some channels are better than the others. So, how do you think when to use which channel? One is expressiveness and the other one is effectiveness. When it comes to expressiveness, under this expressiveness, actually that means we have to match the channel type to the data type itself. And when it comes to effectiveness, maybe sometimes some channels are better than the others as well. So just see channels and the rankings. Channels with the rankings. So position on common scale. Position on unaligned scales. See, these type of lines maybe you might use in Power BI visualizations as well. And the lengths and the angles, tilt, areas, whether it is 2D size or 3D positions, whether it is we just wanted to visualize the depth here, and also color luminance and the color saturation, and also the curvatures and the volume, that is 3D size as well. These are kind of few things which we have to think when we use what type of channels, what are the marks which we are using here. And also for the spatial region, color, hue, motions and shapes. These are kind of few channels which we can use. Okay, is it clear? See, the magnitude channels with the ordered attributes. Magnitude channels, that means we might have ordered attribute. And for the right side, we have identity channels with the categorical attributes. See the difference? පළවෙනි එකේ විශාලත්වයෙන් තමයි අර ඕඩ එක රිප්‍රසන්ට් කරන්නේ. දිග අඩුයි නම් ඒකේ ස්කේල් එකේ ලෙන්ස් එකේ අපි කියනවා මැග්නිටියුඩ් එකේ විශාලත්වයෙන්ුත් පොඩි ප්‍රමාණයක් තියෙන දෙයක් තමයි එතනින් රිප්‍රසන්ට් කරලා තියෙන්නේ. and දිග වැඩි නම් අපිට කියන්න පුළුවන් විශාලත්වය වැඩි දෙයක් තමයි එතන represent කරලා තියෙන්නේ කියලා. Okay, that's how it works. And for the identity channels, may identity channels were that means we have like two different channel types. One is the magnitude types and the other one is the identity type. When it comes to identity channels, when it comes to magnitude channels, that means we generally represent from these magnitude, we generally represent these ordered attributes from these magnitude channels. And also we represent these categorical attributes by using these identity channels as well. When it comes to identity channels, we have spatial regions, color hues, motions, say shapes, and etc. Is it clear? So that's about it. So here what you have to learn is actually we have two types of channels. One is magnitude and the other one is the identity channel. So magnitude channels always differed with the ordered attributes, and for the identity channels, we just use the categorical attributes. So these factors are the expressiveness and also the effectiveness used when we think about when to use these channels here. Okay, that's how it works. So when it comes to groupings and all, so generally when it comes to grouping, containment and the connections matters. So containments, as I told you earlier, we generally marks as links. So marks as links. So here the containments, the dot points. Points will be the containments, and for the connections means the branches, that means the lines. And for the proximity and similarity, proximity same spatial region, and for the similarity same values as other categorical channels. Same spatial region, that is proximity. So proximity, same spatial region, and for the similarity, same values as other categorical channels as well. So here, identity channels with categorical attributes, that is I discussed earlier as well. With these identity channels, we can use categorical attributes. We represent categorical attributes by using these identity channels. Okay. So here with the groupings, we just wanted to consider the containments, connections, proximity, and also the similarities as well. Okay, that's about it. And for the channel effectiveness, generally, when it comes to accuracy, so in this accuracy, actually, we just show how precisely can we tell the difference between encoded items. How precisely can we tell the difference between encoded items? So discriminability, under this discriminability, that is how many unique steps can be perceived. And under this separability means that is our ability to use this channel affected by another one. That is what we think under this separability. And from this pop out, can things jump out using this channel? So to consider the channel effectiveness, we just need to have an idea about the accuracy, discriminability, separability, and finally we have the pop-outs as well. So under this accuracy, how precisely can we tell the difference between encoded items? And discriminability, how many unique steps can be perceived. And for the separability, is our ability to use this channel affected by another one. And for the pop out, can things jump out using this channel as well. As the fundamental theories of accuracy, length is accurate. So whether length is accurate, then we can check whether the length is linear or not. And might be sometimes others magnified or compressed. So maybe sometimes it would be like exponent characterizes as well, characteristics. So for this light blue one, electric shock one, that is kind of an exponential growth. So others we might have the linear actually others are kind of few lengths as well, but they are also we have kind of few curvatures as well. So the length is accurate, that is whether it is linear as well as whether it is curved or not. And for the others, magnified or compressed as well, that is exponent characterizers. Stevens psychological power law. So here I have used kind of an example to show you. So the S means the sensation and I means the intensity. So that's how the graph shows. So x-axis we have the intensity and for the y-axis we have the sensation. And under this accuracy, visually experiments, under this accuracy, we have visual experiments as well. So for the positions, angles, circular areas, rectangular areas, these are kind of few examples which we have to consider under this accuracy visualization experiments. Okay. So here an example shown about the discriminability. That is how many usable steps are there. Must be sometimes sufficient for a number of attribute levels to show. For example, we have line width. Few bins are there. Must be sometimes sufficient for number of attribute levels to show. Maybe sometimes line widths are there. For example, few bins. So here now again we have the separability versus integrality. Separability versus integrality. So here what is happening? Position, size, width and red. Width and color. Position, with position, size, width and color. Color might be the color red and green. So here width and height. So size and the hue would be differed in the second chart. And for the positions and the hue, the color would be differed in the very first example or very first chart as well. So these are few examples to get an idea about what are the separabilities, how can we separate, or what are the separabilities, how can we separate, and also what are the integrities of these charts as well. So first one, it is fully separated, fully separable. The second one, some interferences are there. And for the third one, some significant interferences are there. And for the fourth one, we can't separate those two. It would be like a major interference. So in the first chart, we have only two groups each. For the second chart, we have only two groups each. And for the third chart, we had only three groups total integral areas. And finally, we have the four groups total integrals hues as well. Is it clear up to this point? So the last factor or the last characteristic would be the pop-outs. Find the red dot. How long does it take? There we have to think about how long does it take. So there, find the red dot. There, find the red dot. First, we have to find the red dot. how long does it take? කොච්චර වෙලාවක් යනවද මේ red dot එක select කරගන්න. red dot එක බලන්න, දැක ගන්න. And for the second point, parallel processings on many individual channels are there. So speed independent of distractor count, and also we have the speed depends on channel and amount of difference from distractors as well. And the third point come up under the pop out would be the serial search for almost all combinations as well. So speed generally depends on numbers of distractors. So first one, find the red dot. Generally that means how would it take? How long does it take for this? And for the second one, parallel processing on many individual channels, that is speed independent of a distractor count, and speed depends on channel and amount of difference from distractors. And as the third point, final point, we have the serial search for almost all combinations as well. Speed depends on the number of distractors. See, many channels, tilt, size, shapes, proximities, shadows, directions. These are comes under pop-outs. Okay, give me 1 minute. So here, under this pop-outs, many channels, for example, many channels may be used. That is tilt, size, shape, proximities, shadows, directions, and all. But not all. That is parallel lines, pairs do not pop out from tilt pairs as well. So see, but not all parallel line pairs do not pop out from tilt pairs as well. So here these are kind of few examples which we can show under these differences. So factors affecting accuracy. What are the factors which affects to the accuracy? Those factors are alignment, distractors, distance, and common scale or alignments as well. So here alignments are there, distractors are there, and distance and common scale or alignments also there. So here So alignments matters, distractors matters. And for the distance also matters. And finally, we have the common scale, or else the alignments also matters. So relative versus absolute judgments. So perceptual system mostly operates with relative judgments, and also it is not absolute. That's why that's why the accuracy increases with common frame scale and alignment. That's why the accuracy increases with the common frame or else the scale and also the alignments. So here we have the length, position along unaligned common scales, and then we have the position along aligned scales as well. Okay, these are kind of three different charts which we can draw. So the perceptual system mostly operates with relative judgments. Actually, it's not absolute. That's why the accuracy increases with common frame or else scale and alignment. So the length would be the first one, and the second one you can see the position, and also position along unaligned common scale would be represented. And for the third one, position along aligned scales also represented. Yes. Madam, do you work? Because is the other good night? So here, those are the few differences of these three charts. So that's why the accuracy increases with common frame or scale and alignment. And also on that Weber's law, generally he has mentioned that the ratio of the increment to background is constant. So ratio of the increment to background is constant. And also, so generally filled rectangles differ in length by 1 to 9, that is difficult judgments. And white rectangles differ in length by 1 to 2, that is easy judgment. So when it there might be few difficult judgments as well as there might be few easy judgments as well. So if the lengths are differed from 1 to 9, then we call them as difficult judgments. And with the white rectangles differ in length by 1 to 2, that is kind of a easy judgment. So here relative luminance judgments. So if you see these ones, perception of luminance is contextual based on these kind of things. So contextual based on. So here the perception of luminance is contextual based on. So these factors are comes under what? I guess I have skipped this slide itself. Give me 1 minute. Okay, so here, so the relative luminance judgments, perception luminance is contextual based on contrast with surroundings. And also the second option, so you can see the difference, right? Perception, අපේ මොකක්ද තියෙන අරමුණ මේ luminance වල අර contrast එක වටපිටාවේ තියෙන වෙනසයි ඒ වෙනසවල් හරියටම නිරූපණය කරන්න. So relative luminance judgments under this perception of luminance is contextual based on contrast with surroundings. So here that matters. And that is about the relative luminance judgments. No? So here we have the relative color judgments as well. For example, color constancy across broad range of illumination conditions as well. So here color constancy across broad range of illumination conditions as well. So here that is it. Okay. So these are kind of few examples which you have to consider while you are doing that, while you are making those dashboards or while you are making kind of few visualizations. These are kind of few things which you have to have an idea, or else you have to consider when you are doing those kind of when you are doing actually those kind of issues. Okay, is it clear? So no one is answering. So I hope it's clear with this entire slides. So if you have any questions, you can ask me. If you have any questions, you can ask me at any time, or else you can start a Q&A session also, a discussion on the LMS, so that I also can provide answers for those ones. And also please remember these factors. What are the factors which you have to consider, and what are the theoretical parts, and also how what are these factors means, and how we derive, how we gonna visualize a very clear visualization. How do we do these kind of visualizations, Kela? It's better if you can have a very good idea. So that's all for the this lecture actually. If you all are okay, I can continue with the sixth lecture as well. So what do you think? Do you have any questions? So is it clear up to this point, today's lecture? Can someone give an feedback, at least from the chats itself? Is it clear? Okay, so no one is replying. Seems like you all are not familiar with these ones. And also, okay, that's fine. You can just go through with these lecture notes and slides. So I'll do a recording for the lecture 5 as well. So because we have to cover up another 3 lectures. So this week is kind of 9th week. So we'll cover up those 3 as well. I'll put a recording. So please participate for the practicals as well at the given time itself. If you have any questions, you can come and ask from me. I'm available Tuesdays to Thursdays at the department, so you can come and contact me, come and meet me as well. So thank you all for joining. See you on next day. See you on next week. Please participate the practicals as well. Okay. Thank you all.